So in this video, we'll be discussing the anatomy of a Java program. I'm assuming that you are already familiar with the language. I've created this video in preparation for other security videos that I'd like to make, which require some background in how a program is loaded into the JVM and uses system resources. This will only be a brief overview of the different components of a program. Any of these topics would be interesting to discuss in greater depth, and if there's enough interest, I'll diverge from my planned topics and make other videos based on my feedback. Let's get started. Here are the key players. In no particular order, they are the ByteCode verifier, the class loader, the security manager / access controller, the security package, and the key database. Alright, let's see how they interact. This is a very simplistic view of the program, but will give you an idea of the program flow. Developers make the source file, and the compiler turns the source file into bytecode, which is called a class file. A class file can be recognized with the .class extension. The bytecode verifier verifies the class file, and if it passes, the class loader loads the class, which then executes on the JVM. The security manager and access controller enforce policy restrictions on system resources. In a couple of slides, we'll cover this in a little more detail when we discuss class loaders. You might be asking why bytecode is verified, and that would be a good question. The compiler usually doesn't make a mistake. However, we really need to treat the compiler as hostile. Furthermore, someone with experience would be able to manually edit the class file with some kind of hex editor. The bytecode verifies language syntax, helps enforce memory protection, and ensures that the class file is intact. One important note is that the verifier does not verify all classes. An example of this is the core Java API class files. The class loader loads the classes into the Java runtime environment. The one required class is the primordial class, and it is the first class loader to start the process. This primordial class loader gets the ball rolling and loads the core classes into the Java runtime environment, and from there other classes are loaded in. Each class loader is just a class and must be loaded by some other class loader. Here's where things get interesting. Okay, so when a class loader attempts to load a class file, this is the process that it goes through. The first question to ask is if the class has already been loaded. If it has, there is no further work to do, and it simply loads the class into the JVM. If the class hasn't been loaded, we need to find out if we are even allowed to access the class. If no, then access will be denied. If yes, we determine if the primordial class loader can load the class. If the answer is no, then the class is read from the input stream and is verified by the bytecode verifier. If the bytecode passes verification, we then again see if we have access to it. If access is granted, a java.lang.class object is created. The class is loaded and is cached. This is pretty much the process to load a class into the runtime environment. Okay, and this is pretty much the process to load a class into the runtime environment. The security manager was used with Java 1 and 1.2, but once Java 2 was released, the security manager deferred decisions to the access controller. When an application requests access to a system resource, the access controller grants or denies the request based upon the security policy file. By default, the security manager is disabled, meaning that all system resources are accessible. Okay, let's take a look at this policy file. By default, everything is blocked when the policy file is enabled. So the policy file is a whitelist of authorized activities. The file consists of permissions that are based upon three types of entries: the codebase, signed by, and principal. We can authorize code based upon where it was loaded from, who it was signed by, and who is authorized to execute it. This policy file comes from the Oracle website shown at the bottom of the slide. They have the code for the example game, high score, and high score permissions classes available for review with a breakdown of everything that is going on. For now, I just want to take a look at the policy file and show an example. Let's look at the top block. We are going to grant all code that is signed by Terry permission to access the high score permission class, which has been signed by Chris. We know all code is included since no code base has been explicitly identified. The public keys for Terry and Chris are stored in the key store. Now Java provides a number of security packages. We can see the security interface, encryption, authentication, message, digests, digital signatures, and keys and certificates. Okay, here we have the key database. Not much to it. It's used for storing keys. As an example, we mentioned the key store database a few slides ago in the Java policy file example. Both Chris and Terry's public key were stored in the key database. Okay, and here we have our references. Thank you for sticking with the video until the very end. I promise I will get better.